Not yet. No, the tool is 5th grade, and hi, and welcome to the UCP Institute. We're going to talk about math strategies, and we're going to talk about specifically writing word problems that have a particular concept structure. Oh, good, you can hear me. Terrific. Now, what I want to say is that one of you is teaching 5th grade, and Ms. Torres, which I still can't say your first name, one of these days you and I are going to talk and you're going to tell me how to say it, are teaching 5th and 7th and 6th and so forth. Some of you will have some special needs students in your midst, and some of you may not. I'm using some very small numbers, particularly because I'm not looking at the actual operation that's happening with those numbers. So you can plug in thousands, you can plug in fractions, you can plug in whatever it is. What we're going to look at is the way problems are written so that we can vary them within the work that we present. Now, I didn't get into multiplication and division, which now that I take a look at your grade levels, I probably should have. But that could be done at a further webinar. Right now, we're just going to take a look at the structure for addition and subtraction. So let's get moving. If I can move this along here, where's my next slide? Here it comes. All right. So today, we're going to examine the type of word problems that we need to present in the classroom. We're going to talk about a certain vocabulary that's going to help us when we're actually writing word problems. Because you know, if you've given any kind of assessment before, an FCAT or whatever's coming up, everything's going to be embedded in problems. And so, as much as sometimes you teach operations in isolation, you want to make sure you embed everything in a word problem. And then we are going to talk about different strategies. And so, moving right along here. Oops, look at that. On this particular thing, my solving problems doesn't show. We're going to talk about solving problems and problem solving, which kind of enmesh each other, and also get into the critical thinking that you want your children to do. Okay? Many of them are going to take a problem, they're going to solve it, they're going to say, all right, here's the answer. And with Common Core, or what we call now the Florida Standards, you want to get more to how did they solve that problem, how do they justify their answer, and how do they communicate that clearly. And so that's one of the big issues with a lot of our children with disabilities, because they might come to you with some language processing issues, and when you give them all those words, they go, oh my God, I don't know what the words say, and then how am I expected to solve it, and then how am I supposed to put my language together to be able to make sure that I can convey my thoughts effectively. So that's an issue that we need to deal with, and that's why we're going to look at these problems, and we're going to look at them with small numbers, and I do that with mine all the time. Although mine are 3rd graders, and they're going to get into equivalent fractions, and they're going to get into all of that stuff, but I take this period of time at the beginning of the year using just their partners of 10. And they say, oh, well, we know this, but then I give them the word problem, and they go, I don't know how to solve it. And so that's what I'm doing, and that's what I'm hoping that after this webinar, you'll take a couple of weeks, plug in some numbers that your kids can easily see, and see if they can look at the words, the way the language is presented, so that they can effectively, then you can use bigger, larger numbers or fractions. Now, it also becomes a strategy for them, because many times when my kids get into the thousands, a very simple problem, they look at these numbers, they can't manipulate them in their head. One of the strategies they have is to use simpler numbers. And then they figure out what the words mean, because we've taken 2 or 3 weeks at the beginning of the year, and then they plug back in their other numbers. So let's take a look at that. What factors influence how a student reasons in story problem context? Now, that looks like a lot of words. So let me, instead of asking you and putting you on the spot, let me go, where is it? The type of problem structure. If you've ever given the FCAT, you know that sometimes you look at the problem and you say, man, are they really just trying to make sure my kid's not going to get the wrong answer? Are they putting these words together so that the kids will definitely pick the wrong answer? And I get frustrated because I read these things and I know if I gave it to them worded differently, they would get the answer. And just because of the words, lots of our kids struggle. So that's one of the things that influences how our kids reason. Then the numerical relationship. And I'm going to try it out. The tool, yikes, and Midiala, maybe. The numerical relationships, when you get into fractions, when you're dividing and you're multiplying and all of that stuff, really gets confusing. And so if we can get the problem structure settled, then we can see how the numbers relate to each other and what they mean. And thirdly, the context of the problem. Remember, everything is embedded in a word problem. So you, after leaving this webinar, had better not have a lesson without quite a few word problems. I don't want you to be doing just drill and kill ever anymore. All right, so let's take a look at this particular problem. Aiden has 6 marbles. His friend gives him 4 more. How many marbles does he have? Now, it's a very straightforward structure. I have something, I get more, and this is what I end up with. This is the simplest kind of problem your kids are going to be able to solve. So even if it's a fraction, even if it's 1,000, even if it's 1,000,000, they have that pretty well set up in their head. They got that. Now, do we have a place to start? That's why it's easy. We have a place to start. Do we know what the change is? What we're trying to figure out is the result. And those 3 words are words that I have my kids absolutely label in their word problem. Do you have a place to start? And you'll see that some of your other problems won't have. And if they can start conceptualizing, I have a start button. I know where to press to get my video game going. I have a start. Okay? Now something's going to change. And that's why I'm using simple numbers, and that's why I encourage you to use simple numbers at this point. Something's going to change. If they can start visualizing the action in the problem, then that's where their critical thinking starts. So please, the other thing I need to tell you, I brought my manipulatives with me. I don't care if they're in 12th grade. Please give them something to put in their hands. Because your hierarchy of understanding when it comes to mathematics is concrete, then picture, then symbol representation. And again, I don't care if they're taking trigonometry. You give them manipulatives. And now I don't care if you don't have connecting cubes or anything in your, you've got beans at home, you've got marbles somewhere, you've got something. Put it in their hand and have them demonstrate what does this problem mean. Because many of your students with disabilities, that's where the processing breaks down. Okay? So I will definitely, and have done that this week, given my kids this exact problem and said, okay, here's your 6. You're going to get 4 more. What's happening? What's happening is that you're getting more. It's a combine, it's a join, it's an add, and I keep using all those words. Because with my students with disabilities, one of those words is going to click. Okay? Because many of our kids see the word more, and they go, oh, it's add. and they haven't really even looked at what the rest of the words are. When they get into how many more, they always say more, and they go add. That's where you want to make sure they understand the context of the problem. Okay, so I have them go over, write in their word problem, and write start. This is where I'm starting. Aiden has 6 marbles. Start. And then what I do is I make them write start and put 6. Now tell me what the action is in the problem, because there are going to be some problems that are not going to have action. Yeah, there is an action. Somebody gave me more. Let's do it. Give me more. And then how many does he have now? That's my result. And so I will call 4 more. What changed? What changed? So I have a start, I have a change, and I have a result. And then I will interchangeably use result into sum or product or something like that, so that they start noticing that if it's a multiply, it's a product, if it's an add, and you've gotten through that before, I'm sure. All right, so there we go. Start, 6 marbles, change, 4 marbles, result, and there's my number sentence. And I would have them, for the beginning, many times I don't need to do it more than once or twice, label also the number sentence with start, change, result. Now here's the next one. Thomas has 3 books. Angela gives him more. Now he has 12 books. How many did Angela give him? So notice what's missing is the change. But you have to have that common language so that the kids will say, I know where to start. Where am I starting? I'm starting at 3. Okay, what's changing? Angela gave him more. And now I'm ending up with, this is my result, this is my end, this is my whatever. Now here, I start talking about strategies, and that's what I've got at the end of my presentation, and if I do it now, well, we'll skip the end. I talk about strategies with them. What strategies can you use? Well, some of them will say count on, and that's good. Some of them will say, well, this is really a takeaway, because if I have 12 and I put the 3 here, I can take the 3 away. Notice how the manipulatives get them to think critically. And that's what we're looking for. We're thinking, we have to prime their critical thinking with labels and conceptual things, so that when I say, do you have a start? Okay, what's happening? And show me. Now, it's a little bit, and okay, so I've got 2 strategies. Let me not get too far ahead of myself. I've got 2 strategies. I've got counting on, and I've got subtraction. With some other problems, there would be different strategies. I'm sure in 5th grade math, there's different kinds of strategies that when I teach multiplication, I'm going to give them options for intersecting lines, for groups, for arrays, but lots of different strategies that they can use for number line skipping. And I will challenge each group, okay, you use this strategy, you use that strategy, you use that strategy, and then they come together and they explain how the number line skipping helped me with multiplication, the intersecting lines, the groups, and so forth, and then they have an array of different strategies along with the different words that label the problem to be able to discuss more clearly and justify their answers. Now we're moving on to the 3rd one in the join type problem. Isabella has some cotton balls. Ben gives her 5 more. Now she has 15. How many did she have when she started? So see, I don't have a start button. I don't know where to push to get going. And then I now have Ben gave me 5 more, so it's still that give me 5 more, and I have 15 as my result. So when now I have no start button, lots of kids, this is going to be your most difficult. is that when you don't have a place to start, then you're kind of frozen. And so you have to start with them again with the manipulatives, showing them where it goes and how it works and where you can maybe use subtract, or maybe you can use counting on, or maybe you can use whatever else it is that you plugged in numbers for. But once you give them a vocabulary, and once you give them a format so that their number sentence seems to take a structure, then you've got half the battle done. Because before, you didn't have that language. Well, what changed? You know, what are you looking for? Or, you know, and so now you have a start button, a change button, and a result button. Okay, I have a little video of one of my priceless little boys. Of course, he's younger than the ones you see, but having taught high school and having taught middle school and preschool and all of that, I've found that children come up with the same problems and the same issues no matter what age they are. And so, I'm going to show you my cute little Aiden here. If I can move him over, how can I move him here? Here he comes, right here. And you're going to notice some of the things that I'm talking about with the manipulatives. And let's see if this is going to go.
Had 11 cookies for his lunch. He was a nice friend and gave him 3 cookies. How many cookies did Drew have left?
1, 2, 3, 4, 5, 6, 7, 8.
Very good.
What did he start off with?
He started with 11.
Okay, show me.
11. And then he took away 3.
Alright. Who did he give it to?
Carl.
Okay, so how many cookies does Drew still have left for his lunch?
1, 2, 3, 4, 5, 6, 7, 8.
Good.
Okay, very good.
So, let me move this little guy out here. And move to the next slide, if it goes. There it is. Okay. If you noticed, this little guy was using some of the concept words that I was talking about. He started out with 11, and what happened in the problem, well, he gave, and you saw him using those manipulatives. I'm telling you, if I cannot repeat it again more often, give your kids stuff to demonstrate what's happening. And I even have like 5 gifted kids this year in my 3rd grade math, and I give them. I don't assume that they're going to understand what it is until they've proven to me that, because a lot of gifted kids, what they'll do is they'll do the numbers in their heads, and then they'll shoot out an answer, and it's usually correct, but they can't explain to you how they got there. Well, I just know, and that's what you get. A lot of the things that I've seen with the FSA or Common Core is that that justification piece needs to have clear, concise language. And so that's what we're shooting for with all of our kids. Why was he successful? Okay, because we gave him some vocabulary and we gave him some things to act it out. Okay, and what was it about this word problem that made it easy? Was because the relationship between the numbers was easy to demonstrate. I had this, I took some away, and this is what I have left. What ends up happening more difficult, what makes it more difficult, is when the relationship between the numbers is not clear. And so we'll get to that very soon. Move right along here. All right, so you got the differences problems, which are similar to your subtraction problems, and I don't think that we're up to there yet, are we? Oh no. Oh, this is for you. I forgot about this cute little test here. I want you to take a look at the 3 problems here and tell me how they're alike and how they're different. And so I'll read them to you, and you can respond by typing something. Lucy has 8 fish. She wants to buy 5 more. How many fish would Lucy have then? And then TJ has 13 chocolate chip cookies. At lunch, he ate 5 of them. How many cookies did TJ have left? Janelle has 7 trolls in her collection. How many more does she have to buy to have 11 trolls? So think through those 3 problems and type what you think is alike first, and we'll discuss it. And then type through what you think is different, and we'll discuss that. And I'll give you a little music to go along with that, the Jeopardy tone. And I don't see anybody typing yet. Maybe because I need to be more quiet. What's different and what's alike? Nobody wants to venture. And I'm not one to usually give out answers. Nobody is venturing. No one's typing. Oh, Miss Torres is going to take a stab at it. I teach reading. That's an excuse? But, let me tell you, reading, that's why it's difficult for me, yes. Except that you might want to consider during your reading to look at some math problems as some of your nonfiction reading, because if comprehension is the key, then you could be helping out both the reading and the math teacher at the same time. All right, so since you have a legitimate excuse, then I will give you the answer, okay? All right, just to talk through your word problems. Lucy has 8 fish. Do we have a start? Yes, we do. She wants to buy 5 more. We have a change. How many fish will she have? Then we don't have the results. TJ had 13 cookies. At lunch, she ate 5. So she had a start, and you've got a change, and you're looking for the result. So in the first 2, you have that standard. I have my start, I need a change, I need a result. Janelle has 7 trolls in her collection. How many more does she have to buy to have 11? All 3 of those have a start. The last one doesn't have the change. It has the result. And that's how you know that they're alike, all 3 of them, but the last one has a bit of difference. And here's our little chart that we have. The action in these problems is joining. So if you're taking a look, now we're not looking at the problems that we just discussed, okay? The 3 problems we're looking for are under here in the chart. So result unknown is the easiest one. The change unknown is slightly more difficult, and the start unknown is the one that's the most serious, difficult comprehension. All right. This one is a separate, and they call it separate because of the action, okay? So that when you join something, you're adding. When you separate, you're taking it away. I like for my kids to use separate or take away rather than minus. Some of them will say 12 minus this or that, because minus conceptually doesn't click. Okay? If I'm separating something, it's easier to conceptualize. And so even with your older students, I would probably use those words, separate or take away. And so 11 children were playing in the sandbox. Some children went home. There were 3 children still playing in the sandbox. How many children went home? This one is going to be most difficult for them because it's not going to be the most difficult because you don't have the change. You've got the start button and you've got the result. And so instead of going through every single kind I've just got this chart here for you. It's similar to the addition kind. And so here's the separate and the words that can help you. Now, when you're sitting down and you're writing word problems, and this goes for my 5th grade math teacher there, even though Ms. Torres has an excuse that she's teaching reading, please have that chart with you. And I wish I had included the multiplication now that we're going through this a little quicker than I thought, because it has similar words to it that help you write word problems and make sure you cover all the different kinds of word problems that they'll get presented. And so for me, when I just say, okay, I haven't done a separate with a start unknown, I know what I'm going to write. The other step you want to make sure that your kids do at any age is you want them to write their own. There's a higher level of thinking and a higher level of critical decision making that happens when the kids have to take a number sentence with a variable somewhere and they have to write their own. You think they have it because you've given them word problem after word problem and they solve it, and then you say, here's the number sentence, write me a word problem. It just doesn't happen. And so that's also really good practice for all of your kids to make sure that they're conceptualizing how word problems go at any age. All right, so context of the problem. Whenever you are presenting a problem or whenever your kids are writing problems, can the student see the action in the word problem? And we're going to get very soon to where there is no real separate or join. There's no real action. Is there an action in the problem? Can they act it out with manipulatives? Can they write a number sentence, draw a picture, label the number to represent what's happening in the problem? And those will be all kinds of different ways for you to assess. So if you're in a school that has to write up, the 4, 3, 2, 1 rubric, see if you can add some of those into, can they do this, can they do this, can they do it, and put them in hierarchy so that your kids who are actually writing a word problem to match a number sentence are at that level 4, if that's helpful at all. And I don't know how many of you have that number sentence. At UCP, we don't need to. So here's the one with no action, and the one that trips up kids a bit, okay? Because if you take a look at, Connie has 5 red marbles and 8 marbles are blue. How many marbles does she have? It doesn't really tell you to put them together. So there lies where you have to start talking about part, whole. And that goes for anything, because I use it with fractions, and I use it with decimals, and I use it with lots of different things when my kids get through towards the end of 3rd grade, and my gifted kids start right away. Now, the other one, Connie has 13 marbles, 5 are red, and the rest are blue. How many are blue? Is similar to that. And you'll see the whole is unknown and the part is unknown. And you have to make sure that either part is unknown, not just the first one. Okay, so here's my whole. And I use this actual, I have maps. I call them part, whole maps. And I put whole and I separate some in 2 and I separate some in thirds. And that helps me when I start with fractions too. So if they can get this, then they get a concept of pieces of a whole. And then you have to go into the fraction where the pieces have to be the same size. And so therein lies that. Let me see if I have to continue with this one. And we're going to skip that one. Okay, now let's talk about relationship between the numbers. And if you're in 5th grade math, this gets really difficult. I know that you're going to get into the order of operations and you're going to get into all sorts of fraction work and so forth. Believe me, when I taught 5th grade math, teaching multiplying fractions and dividing fractions, my kids never got it. For some reason, because I wasn't giving them the things to hold. I was always going, well, we're taking this algorithm and we're flipping this. When it's divide, flip it and make it a multiply. And they were looking at me like, okay, and I'm remembering just the steps. I'm not getting it. I'm not being able to talk about it. And I'm not able to make sure that I can give them all the different kinds of problems so that they experience all the relationship that can happen between the numbers. And so, where there's action in the words, the relationship is easier to see. But then when you get to how many more and how many less, the relationship ends up different. And I don't know. I'm going to try this year. But I would like to be able to take that word more out of their vocabulary and not say that more is always add. I don't know what I'm going to do to be able to solve that problem. All right. So I went through how many more, how many less pretty quickly. And I'd like to make sure that you can see when I do how many more and how many less, I make sure that I have these. And it's easy to see the how many more because I can break it off. The concept of how many less is different and much more difficult to see perceptually with our kids with perceptual problems is how many are missing here. And so if that becomes the case, sometimes graph paper is better. And I know that when I was doing fractions, graph paper was awesome. Just keep in mind that our kids with perceptual problems, visual problems, the kids that you have with dyslexia, the kids are not going to see that really well. So you have to figure out different ways to deal with that perceptual problem. And we dealt with some of that in the accommodations webinar last time. And so if you're interested in talking about, learning a little bit about perception and how things are visually, you have to make the accommodations for, you can go visit that particular webinar that I've done the last time. Okay, now I'll move on. And we're going to review a little bit, particularly because we have a reading teacher amongst us. So, the types of word problems we present in the classroom cannot be this plus this equals this. This times this equals this. You have to make sure that when you're doing the when you're presenting and writing the problem, don't depend on your book. The nicest problems you can do are the ones with your own kids' names in them, or the ones that your kids have written and you say, this is Aiden's problem, this is Jessica's problem, and the kids get a real kick out of having either their name in it or they own it. And so let's make sure that the kind of problems we present are varied and that we use a common language to help them identify the different pieces. Okay? Now, I'm going to stop talking just for a little bit, just in case you have problems, questions, comments. We're at least 3/4 of the way here. So, anybody need to say something before I move on? Yes? No? Nobody's talking? Oh! He's here. No comments? I'm glad you're here. All right. Ready? You got it? All right. Perfect. And let's move on. Okay. This is a complete chart of your join and separate problems. And what happens, what the bottom of the chart says, okay, is the kind of hierarchy that you want your kids to go through. So, when you're using the problem or any kind of problem you present, okay, you want them to do some direct modeling. You want them to do some direct modeling. You want them to do some counting on. You want them to do some some matching. You want them to do some trial and error. What I tell my kids all the time is that I want you to get it wrong. And cognitively, that's the best thing that can happen. I want them to get it wrong so that we can solve it together. Because if you know anything about brain, teaching with the brain in mind, is that if they get it, it doesn't build a lot of connections. So that you have your neurons that have one piece that's an axon and another piece that's a dendrite. And when the neurons connect, with your dendrite connecting up to your axon, little tiny pieces of protein connect both together. So I present a problem, this kid gets it, and I've got this one little piece that's connecting these two neurons, and that's it. I'm going to practice it again, and I'll get it again, and then I'm going to sit down. So this is not a solid connection. But if I didn't get it right, if I got it wrong, then I've got to call on some more neurons. And I've got to categorize my stuff differently. And then I build these dendrites that are all connected up to all different kinds of... So the more I do it, the more I try it, the more I get it wrong in that whole trial and error system, the stronger my learning happens. So that's why I tell them, don't get discouraged, because I'm happier when you get it wrong and fix it rather than get it right the first time. Because I know learning's going to happen more if that happens. So you got your direct modeling, then they do their whole counting thing, and then they use their number facts. So if you can look on the left-hand side of the chart, that's what's happening. And then on the right-hand side, you've got the derived facts. So that derived facts are those benchmark numbers that they're going to use in order to, so with multiplication, if they know their 2s, their 5s, their 10s, their 11s, then you've got benchmarks to go to so that they can derive a fact. If they know their 5, then they can get to a 6 times table, and so forth. So that too is going down, and then the bottom on the right-hand side, it says derived facts, and then it says recalling. Then that's when they know their facts, and they just recall them, and they do it. So a lot of these problems that I showed you at the beginning, many of your students would be able to go 4 and 6, just derive the fact and know it's 10, and know right away that it's a recall. And hopefully at 5th grade, most of your kids might know their multiplication tables. I'm hoping. All right. So, we were going to have a discussion on what kinds of strategies your students could take to solve these problems. But remember, I talked about those at the beginning. I want just right now, instead of continuing into more different kinds of strategies, is to make sure that they solve the problem one way and then use another strategy to solve the same problem. There are times when I will give them this when they really need place value blocks. And I'll say, okay, we don't have place value blocks today, so this is how I want you to use the manipulatives to solve this problem. Figure out what you're going to do. Maybe some of them will say, okay, the black will be my hundreds, and the yellow will be my tens, and the green will be my ones. Sometimes that really is kind of an awesome activity to give to your higher functioning kids or your kids who are fast finishers. Say, okay, you're able to solve it with this. Now I'm going to take that usually happens and give you something that's odd. Go figure out the categories. Go figure out how this manipulative can help you, and they have to design that whole thing like I just said. So that's really challenging for some of our fast finishers. And manipulatives we just did. All right, let's talk questions. Okay? If the video that you had seen a few minutes ago, if he had had some problems, and I went over and I said to him, hey, you know what, let me help you with that. Look at, this is what happens, and this is how it did, and then I would have defeated the point of this entire lesson. Okay? And so it's the hardest thing is to close your mouth and try and think of the right question to ask so that you're not just going over there and fixing the problem for them. You have to really practice with yourself to say, well, how come you did this? And where did that come from? And are you sure this is what? Show me what you're doing. Does that really make sense? How come? And take them through a task analysis that, again, we're looking for trial and error. We're looking for them to get those dendrites and those axons and those protein strips to connect together. And that's where you're going to be able to do that most effectively by not giving them the answer and keep asking questions, guiding them in the right direction until they go, oh, wait a minute. I had a little boy who was struggling with, he had $15 and 3 friends. And how many dollars does each friend get if he wanted every friend to get the same amount? Well, right away he told me 5. Could not explain it to me. Again, that whole language processing. So I went through the whole question. Well, how do you know? How do you know it's 5? Oh, because I just know. Show me how it's 5. And how do you know that? And they finally said, well, no, because if I give them all the money away, I won't have any left. Cute, but not where I wanted to get to. But it allows you also to walk around your kid's head. Well, he was really struggling with that. He didn't want to give his money away to begin with. And sometimes that's the stumbling block with some of our students with special needs, because they get stuck on, I'm going to give all my money away and then I won't have any, and so I'm not doing this problem. And so if I go over there and I don't ask questions, then I don't know what's in the way. Is it because I don't want to give my money away? Or is it that I don't understand what the concept is? Many of our ASD kids are going to get stuck with that sort of thing because they're thinking differently than we are, and we have to ask and we have to figure out what the stumbling block is and then talk them through it. Okay, so that was my little spiel on questioning. So, see, I told you we were almost at the end. Here we go. In review, I want you to have understood the importance of presenting problems in a variety of different problems and in a variety of different ways. I want you to understand that each kind of problem has a structure and a relationship between the numbers and a context in which you want to put those numbers in. So even if I didn't do the multiplication and I didn't do the fractional and so forth, if you go and you sit down and take a look, you can use your own kind of language if you wanted to figure out concept words so that your kids can get and use those words to structure their problem. And they're your own, and maybe you can give the next webinar. And then understand the importance of having students use a variety of different strategies and explain and justify their answers. Because explaining and justifying their answers is going to be part of what we expect our kids to do with the FSA, which is the Florida Common Core version of Common Core standards. Okay? So, if you want your 3 credit hours or CEUs for this webinar, you have a little bit of homework. And here's your homework. You can write a total of 15 problems. I don't care what they are, addition, subtraction, I don't care what the numbers are. And then make sure that they depict all the different kinds of problems that we were talking about today. And then write a number sentence and use the vocabulary to label the numbers. Or you can describe a lesson in which you use some of the word problems and strategies we discussed today. So, Ms. Torres, if you're doing your reading group and you spend 15-20 minutes on word problems, you get this. Reflect on your students' teaching and use the manipulatives and how they solve the problem. Or, if you're brave and you want to videotape a lesson, you can do that and show me one of the types of problems. It doesn't have to be, in fact, if you're at 5th grade and you'd rather do a different problem than the ones that we presented today, go right ahead. I just want to see your kids being able to use the structure, the label, so that they have some conceptual framework, and hopefully this will help. Now, you can email your homework to amorin@ucpcfl.org, and she looks at it and sends you a certificate. And Ms. Torres is typing. So I'm going to wait a moment because she probably has a question. Thanks, it was a great. Oh, she always is so kind to me. And I think that's it. Nope, just me at the end. So if you have some questions and you want to email me at any time, I'm available too. This, I know that somebody from the last, and I don't know if it was you, Ms. Torres, was asking about what the requirements were and you didn't get the homework or something. I'm going to go back to the homework page so that you can jot it down now. I don't know how quickly it gets up on the UCP website. So I'm going to leave it up for a few minutes in case you want to just jot down what it is before. Because somebody emailed and said, I don't remember what the homework is, and can you please? So hopefully if it's not up, you can jot that down right now before I say goodbye. And send in your homework to Amorin so that you can get your 3 CEUs. You know, you need 20 before the next time that you get your certification renewed. So this is kind of incentive for you to do your homework. Tell me when you're done copying, and I can say goodbye. And I will see you hopefully next time. There are others coming up. I am going to do one on brain teaching strategies. You might be interested in that one. That's coming up later on. So as soon as you let me know when you finish copying your homework, I can exit off. They must still be copying. Still copying? Just tell me when you're ready. Now click off the homework page, and I'll leave you to go have some dinner.